Okay, welcome back. Sorry about that, had a little audio feedback. Welcome back, everyone, to Grockit's OGTV GMAT edition, where we're going through the 12th edition of the test guide, right there, 12th edition, Grockit, right there, taught by Jim Jacobson. That's me. I got a new template to draw on. And when we last left off, we were on page 159. Question number 49. I forgot to mention this is Grockit OGTV where we go through all the questions. But if you've tuned in for this, you probably already knew that. So, number 49. B, C, D, and E. I'm going to write out the numbers rather than spelling them out. 4, 3, 2, and 1. How many integers n are there such that 1 is less than the quantity 5n plus 5, and that in turn is less than 25? So we have 5n plus 5 in the middle here, less than 25, and more than 1. One of the things to remember about inequalities is that you can treat them like equations. You can add and subtract, multiply and divide. The only thing you can't do, or at least shouldn't do without careful consideration, is multiply or divide by a negative number. So as long as we are dealing with things that are known to be positive numbers, we can leave the directions of the symbols the way they are and simplify putting n in the middle of this. So the first thing that looks like a good choice to do is going to be to subtract 5 from all three elements. We are going to end up with negative 4 here. 1 minus 5 is negative 4. We're going to end up with 5n on its own in the middle. And here we're going to end up with 20 on that side. Again, the goal here is to isolate n. So then we divide by 5. We end up with negative 4/5 here. N ends up on its own. And then 4 ends up here. Of course, we're solving for a range of values for n, not just n itself. So n is greater than negative 4/5 and less than 4. And we're wondering how many integers are there in this range. So 4 itself cannot be considered. So integers are things like 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, etc. N has to be less than 4. So this is one of the boundaries of our value for n. And also has to be greater than negative 4/5. Keep in mind that negative 5/5 is the same thing as negative 1. Negative 4/5 is slightly less negative than that, so n is short of negative 1, but greater than 0. So the other boundary is here, so we call this 4 and this negative 4/5. We count the integers in our little list here, 1, 2, 3, 4. There are 4 integers for the value of n that satisfy the original equation. So answer choice B is the correct answer. Everybody wins. Okay, on to the next one. Still page 159. Question 50. Two, three, four, 5. So if y is an integer, then the least possible value of the absolute value of 23 minus 5y is what? So we have the absolute value of 23 minus 5y. So the thing to remember about absolute value is that absolute value is the distance of a number from 0 on the number line. 0 is the lowest possible absolute value. The larger the absolute value gets in either direction, the further it is from 0. So really, we want 23 minus 5y to be as close to 0 as possible. So we want it to be, the lowest number on this list as we can get it. the way to get 23 minus 5y as close to 0 as possible is to make 5y as close to 23 as possible. So, I mean, if we just had 23 minus 5y equals 0, well, it wouldn't actually equal 0. But in order to get this, we would need to get whatever this expression is as close as possible to it. Well, we would need to get it exactly equal if we had an equation here. Now in this particular case, y is an integer, so we can't actually have 23 minus 5y equals 0. But we do know that 5 times some integer has to be very close to 23. So 5 times what is close to 23? So basically the two numbers that are close, 5 times 4 is 20, and 5 times 5 is 25. Those are the two numbers that get us closest with 5y to 23. So we have y equals 4 and y equals 5 to worry about. So when y equals 4, we get the absolute value of 23 minus 5. Well, it's the same for both of these. I guess I could do both of these right away. We substitute the value in. The absolute value of 23 minus 5 times 4 is 20. This one will be 23 minus 25, because 5 times 5 is 25. 23 minus 20 is the absolute value of 3, which is 3. 23 minus 25 is the absolute value of negative 2. But remember, with absolute value, it's just an absolute, it's a distance, so without regard to sign, without regard to direction. So the absolute value of negative 2 is 2. We wanted the lowest possible value. That's we got there with y equals 5 rather than y equals 4. It's possible to go over the number and still be closer because we're just looking because of the absolute value function. That gives us choice B. That is the smallest possible value. 23 minus 5y equals 2, as long as y equals an integer. Okay. On to the next one. Number 51 on page 159. All right. A, B, C, D, E. We have 98, 49, 28, 21, and 14. Interesting to note that all of these are multiples of 7, which isn't surprising then when we see the question. So the quantity, the square root of 7 plus the square root of 7 squared equals what? So we have square root of 7 plus square root of 7 quantity squared. What does that equal? So remember, when we are doing binomial expressions and we're squaring them, so if we have any two numbers, if we have x plus y quantity squared, this one's worth memorizing actually, as is the difference of two squares, x plus y, or x squared, the reverse things, x squared minus y squared, and things like that. You need to be able to, what I'm trying to say is you need to be able to go backwards and forwards from x plus y quantity squared to x squared plus 2xy plus y squared. And really all this is FOIL. If we were to write this out, x plus y times x plus y. The first terms, those lead to x squared. The last terms, those lead to y squared. And then the middle terms, the outer and the inner in. That's enough. FOIL. The outer and the inner terms, each of them is an xy, so we add them together and we get 2xy. Anyway, worth committing to memory if you have spare brain space. So this one is going to follow exactly the same format. X squared is going to be the square root of 7 squared. When you square square roots, you just get the original number. So let's actually just write this again over here so we can keep the terms straight. That's what that's going to equal. So this is square root of 7 squared, which is 7. 2 times x times y. So our middle term is going to be our middle term is going to be 2 times 7 again, because maybe I should write that out to make it clearer. So we're going to write 2 times the square root of 7 times the square root of 7. This is our x, and this is our y. And then y squared is going to be the 7 at the end here. So remember, though, the square root of 7 times the square root of 7 is the same thing as the square root of 7 squared. So this just ends up being 7 plus 2 times 7 plus 7. That's a plus, not a 7. So 14 plus 14 equals 28, which is answer choice C. Note that the trap answers are all, like I said, multiples of 7, and so if you misunderstood how to approach this question, it's pretty likely that your answers would bring you close to, one of these other numbers if you did things a little bit differently and wrongly. So, on to 52. 159, number 52. There's some ratios here. I'm going to write them out in short form here. Come on, give me dots. There we go. 1 to 2. The pen does not want me to do little dots. 1 to 3, I'm going to write them out. 1 to 4, 2 to 3, and 3 to 4. So in a certain population, there are 3 times as many people aged 21 or under as there are people over 21. The ratio of those 21 or under to the total population is what? So we have 2 different groups. We have those who are 21 and over, and then we have those who are under 21. This is a certain population. There are 3 times as many people 21 or under. Oh, I messed this up. So it actually, this should be over 21, and this one should be 21 or under. I don't think it would have messed up this problem, but I should do this the right way. So the ratio of those 21, so we were doing the actual ratio here. 3 times as many aged 21 or under as there are people over 21. So for every 1 that there is that's 21, there are 3 times as many 21 or under, which means there are 3 of these for every 1 of these. The ratio of the 2 together is 1 to 3. Of course, this is the trap answer. Because the question isn't actually asking us what the ratio of the 2 is. That's actually given right in the question. We're being asked what the ratio of those 21 or under is to the total population. Now, again, we're not being given the actual total numbers here, just the ratio. One thing we do know is that, so when you're given the parts of the ratio, in this case, 1 to 3, we know that each of them is out of 4. So because there's 3 in this part and 1 in this part, in order to have 3 times as many people as this number, you need to have at least 4 people in the group. Likely this certain population is larger than 4. It's probably a multiple of 4, but whatever, well, no, it has to be a multiple of 4. But in any case, the total population is a multiple of 4, and then the individual populations are multiples of 1 and 3, respectively. What do we do with that? So we need to know the ratio of those 21 or under, that's the 3, to those to the total population, which is 4, 3 to 4. Answer choice E is our correct answer. These other ones, 2 to 3, 1 to 4, 1 to 2, these all hinge on misunderstandings of what it is you're trying to figure out. 1 to 4 is a trap. This is the over 21 to the total. Yeah. The other ones, I'm not actually sure where somebody would come up with these, but we didn't do that because we're smarter than that, or better prepared, or both. Okay, we shall move on. On to number 53 on page 159. And then we have some answer choices. We have 6, 12, 24, 36, and 42. In the figure above, the value of y is what? We have a figure above that looks something sort of like this, but the lines are straighter. We have 2x degrees there. We have 3x degrees there. And y plus 30 degrees there. So this one's all right. We have a couple different ways we can go about this one, but really, because we need to solve for y, basically it makes it clear that we have to solve for x first. Remember that complementary angles, and that's spelled with an E, in case it matters. Complementary angles with an I would say, hey, you're pretty smart for a person or something. I don't know. I was imagining that it was giving you a compliment. It's my little joke. Complementary angles with an E are angles that complete each other. And in this sense, they are complementing each other to add up to 180. So all the angles in a straight line, in this case, I'm just going to use a different color. So we're using a straight line here. All the angles in the straight line add up to 180. So we know then that 2x, the one angle, plus 3x, that equals 180. So 5x equals 180, and x equals 36 degrees. So of course that's our trap answer. We figured out the value of x, but the question is actually asking what the value of y is. So trap, watch out. Okay, but this whole idea of complementary angles could also work. So we could use, I'll do a different color here. We could do this pair of angles equaling 180. We can also do vertical angles. Vertical angles are the ones that are directly opposite each other. So it's this angle here and this angle here. And that one's going to give us the smaller number since we're just dividing by 2 rather than dividing by 3. Well, not the smaller answer. Y will be the same no matter what. But here we would set the angles equal to each other. So let's do that. So we know that 2x equals y plus 30. Those two angles have the same measure. We also know the value of x. So 2x is 2 times 36, which is 72, equals y plus 30. Subtract 30 from both sides. We get 42 equals y. Answer choice E. I'm not sure where these other, not every trap answer or not every wrong answer choice is a trap, or at least not an obvious one. Sometimes they're just numbers meant to fill in to give you a range in case you have a computational mistake somewhere along the way. So, answer choice E, correct one. On to number 54. Still on 159. Okay, we have 9 times the square root of 5. 20 times the square root of 5. 41 times that square root of 5. The square root of 205 and 100. 100 being the only one without a radical sign in it, which is interesting. Meant to attract your eye for sure. So the square root of 80 plus the square root of 125 equals what? So some things to remember. Let's just get this up on the board. Square root of 80 plus square root of 125. So remember that when you're dealing with radical signs, if you have the square root of x times y, that equals the square root of x times the square root of y. But if you have the square root of x plus the square root of y, that does not equal the square root of x plus y, which is what we have in this case. So we can't simply add together 80 plus 125 and get 205. That's this trap answer right here. It's not that easy. So not choice D. We can, however, do a little distribution so that this guy ends up being more useful. So one of the things that we want to do then is see if we can get some perfect squares out of each of these individual elements. So by dividing out, actually the answer choices kind of help us out here. All of these guys have a square root of 5 in them. That's a thinker. So let's actually divide both 80 and 125 by 5. So 80, the square root of 80 is the same thing as 5 times something. Come on, give me the dot. There we go. In this case, it's actually 5 times 16. And here we have, this is the same thing as 5 times 25. That's a dot. Come on, do it. Now, when you have a common base, you can redistribute them. So this is the same thing as 5 times the square root of 5 times. So we're using this rule here to unpack these two bits. The square root of 5 times the square root of 16 plus the square root of 5 times the square root of 25. And here we actually can do some of the math because we know what the square root of 16 is and we know what the square root of 25 is. So here we have 4 times the square root of 5 plus 5 times the square root of 5. Because, you know, we leave the square roots of 5 where they are. We can't do anything with those, but we can figure out that this is 5 and then this one is 4. And then I just switched the order around because normally we put the coefficient, the non-radical coefficient before the radical. So 5 times the square root of 4, 4 times the square root of 5 plus 5 times the square root of 5 equals 9 times the square root of 5. Answer choice A is our correct answer. It does look like this 20 times the square root of 5 maybe is assuming someone might mistake addition for multiplication here. But even if this were true, 4 times the square root of 5 times the square root of 5. Oh, actually, that would, no, that wouldn't equal 100. That would equal 125. Never mind. I thought maybe this was the trap answer leading down here. Yeah, this one just leads to other types of mistakes. Anyway, 9 times the square root of 5 it is. Victory is ours. Last one on page 159. So A is 1 to 6, B is 1 to 4, C is 2 to 5, D is 3 to 5, and E is 2 to 3. So Kelly and Chris packed several boxes with books. If Chris packed 60% of the total number of boxes, what was the ratio of the number of boxes Kelly packed to the number of boxes Chris packed? So we know we have Kelly Chris. And we know that Chris packed 60%. It doesn't even matter how many Chris actually packed because we're dealing with ratios the whole time. Percents are ratios, as are, all of the answer choices, 1 to 6, 1 to 4. Those are all different types of ratios. Percents just happen to be ratios out of 100. Just as a reminder. So if Chris packed 60%, which we get from the problem, and Kelly and Chris are the only two people doing this, Kelly must have packed 40%. So then what we're after here is the ratio of the boxes Kelly packed, 40, to the number of boxes Chris packed, 60. And we could leave these as percents, or we could just pretend that there were 100 boxes and Chris did 60 and Kelly did 40, or they did 10 boxes and Chris did 6 and Kelly did 4. Either way, the ratio should be Kelly's number on top, Chris's number on the bottom, because that's what the question asks for. 40 to 60 is the same thing as 4/6. We divide by 10. We can still reduce it further, but divide by 2, 2/3. Do we get that in the answer choices? Yes, we do. 2 to 3 is the same thing as 2/3. Again, ratios can be expressed as fractions and vice versa. You may have been able to do that in your head, but you could be given a question where the percentages were not nearly so clear-cut. So in this case, it's best for me to show the method so that you can apply it to multiple GMAT questions. Anyway, choice E is the correct one. In terms of trap answers, this is just what Kelly did on Kelly's own. Kelly's a unisex name, could be male or female. Same thing with Chris. So this is what Chris did on Chris's own. So these are two trap answers. The ratio of each of them to the whole. And I have no idea what these other two are, other than they both use, numbers from the actual problem. In any case, that was the last one on page 159. On to page 160. 160, question number 56. So A is 1/10, B is 1/8, C is 1/4, D is 5/4, E is 25 halves. Goodness. Interesting. Anyway, so of the following, which is the closest approximation of 50.2 times 0.49 quantity divided by 199.8? Let's put that down on paper, e-paper. 50.2 times 0.49 divided by 199.8. Now, obviously, with all these decimals and the fact that it outright says approximately in the question, we know we're going to have to do some estimation here, and we just have to make sure we do so correctly. Of course, this comes down to some basic rounding, and then we're probably going to want to get things in fractional form because all of our answer choices are expressed as fractions. I mean, the whole thing here is expressed as a fraction, but we have decimals. We're trying to get rid of those decimals. 50.2 is closest to, yes, 50. It's only 2/10 of a unit of a number more, so that's a good approximation. 0.49 is almost the same as 0.5, which is the same thing as 1/2. 199.8 is so close to 200 it could probably taste it, so let's just leave that as 200. So then we are left with half of 50. 50 times 1/2 equals 25 over 200. And then we have to reduce this as a fraction. 25 goes into 100 4 times, so 25 goes into 200 8 times. That is the same thing as 1/8. Answer choice B is our correct answer. a little quiz, not really a quiz, how do I put this? A useful task for yourself. Imagine for a second that, no, okay, let me explain why this is important. So is this number here, is this larger than 1/8 or smaller than 1/8? Think about that one. There are questions on the GMAT where you can eliminate wrong answer choices just by being able to correctly estimate which way a fraction goes. So when you're doing your approximation, it's good to know whether your approximation is too high or too low, because then you can eliminate answer choices that go in the other direction. So that's a little thought project for you. Is this bigger than 1/8 or smaller than 1/8? It doesn't matter for purposes of getting this one right. It matters for getting other ones right on the GMAT. And you should be able to answer why this one is bigger or smaller than 1/8. And I'm not going to tell you right now. You have to figure it out. Haha. Anyway, think about it. So page 160. Number 57. We have 15, 25, 35, 45, and 55. The average of 10, 30, and 50 is 5 more than the average of 20, 40, and what? So we have a couple different ways we can go about this one. Let's just stick to the straightforward way first before we do any shortcuts. An important formula to remember, the average formula. This should be your friend on test day. The average equals the sum of the numbers that you're doing something with over the number divided by the number of numbers. Useful all the time. And sometimes GMAT problems will ask you to apply the average formula more than once in a question, and this is just exactly one of those. So the average of 10, 30, and 50 is 5 more than the average of 20, 40, and what? So the average of 10 plus 30 plus 50, and there are 3 numbers in there, so we have to divide by 3. This ends up being 50 plus 30 plus 10 is 90 thirds, or so the average ends up being 30. Now, we could have saved ourselves a little bit of effort just by kind of looking at how these numbers are distributed. This won't work every time, but whenever you can do this to save yourself a little bit of math, you save yourself a little bit of time. Note that we have this number here, which is 30, this number here, which is 50, which is 20 higher, and then this number here, which is 20 lower, which makes the middle number the average to begin with. We didn't even have to do the average formula to figure out that that was the average. This sort of extra time-saving thing, I mean, gosh, how long did it take me to do 10 plus 30 plus 50 divided by 3? I mean, that might have been 20 seconds, and I had to read it out loud. When you were doing it for real on the GMAT, it isn't going to take you that much time, but if you can accumulate these little time savings over the course of the test, it can make a difference. Anyway, we aren't trying to figure out what the average of that is. We are trying to figure out what the average is of this new set of things. That is 5 more than the average of 20, 40, and what? So 20 plus 40 plus this mystery number x divided by 3 is 5 less than the average we just figured out, because remember we just found that it's 5 more than this. So is 5 more than that. So this needs to be 5 less. We know that the average equals 25. From here, it just becomes an algebra problem. We multiply both sides times 3. 20 plus 40 plus x equals 75. That ends up being 60 plus x equals 75. Subtract 60 from both sides. We get x equals 15. A equals 15. I don't know that there was quite the same shortcut that we could have done with the average, on this equation here, but that's okay. You can't expect there to be a shortcut on every problem. If I had to estimate, it might even be fewer than 20% of the problems will have a major shortcut, but you know, that's still a significant number. And of course, it always feels good if you see a quick way to do a problem more quickly. And morale is important on the test too. So anyway, on to number 58 on page 160. So we have 34, 31, 14, 11, and 7. In the equation above, so the equation above is y equals kx plus 3. So in that there equation, in the equation above, k is a constant. If y equals 17 when x equals 2, what is the value of y when x equals 4? Okay, so the value, if y equals 17 when x equals 2, that gives us 2 of the variables in a 3-variable equation. So we could actually solve for the value of k given those numbers. So y equaled 17 when k times an x equaled 2 in this instance, plus 3. We can subtract 3 from both sides and move, and so we end up with 14 equals 2k, therefore k equals 7. Now we need to do the whole thing again because we need to know what the value of y is when x equals 4. So let's do that equation again. Same thing, y equals kx plus 3. But now we're replacing different things. We don't know what y is. Y equals k equals 7, remember. And we're trying to figure out what this is when x equals 4 plus 3. 7 times 4 is 28. 28 plus 3, so y equals 31. Note the big trap answer here. Again, classic GMAT trap is to give you a value of a variable that you solve partway through the process of solving the entire problem. Because we solved for k equals 7 here, some people may throw up their hands in delight and say, aha, eureka, I have found it, and see that in the answer choices. Of course, that wasn't all the way through the problem. Anyway, okay, so choice B, 31 is the correct answer. Number 59 on 160. I'm sorry if you can hear that motor running outside my window. Nothing I can do about that. Okay, so we have 35, 36, 37, 38, 39. So each week, Harry is paid X dollars per hour for the first 30 hours and 1.5x dollars for each additional hour worked that week. Each week, James is paid X dollars per hour for the first 40 hours and 2x dollars for each additional hour worked that week. Last week, James worked a total of 41 hours. If Harry and James were paid the same amount last week, how many hours did Harry work last week? So, lots of words in this one. That's as long as some critical reasoning passages. We are given James's total hours for the week, so we can figure out how much he earned, at least in terms of X, for that week. So James at 41 hours. So he earns X dollars per hour for the first 40 hours. He worked at least 40 hours, so that's 40x. And then he gets 2x dollars for each additional hour earned for each additional hour beyond 40. Now he only worked 1 hour beyond 40, so that's just a straightforward 2x. So his total in terms of x, we don't actually get the number of dollars, but we get it in terms of x, that equals 42x. And since Harry's pay rate is also in terms of x, we can just set his rate equal to this. So let's say that, so now we're trying to figure out Harry at his number of hours. Yeah. So we know that Harry is going to make 30x for the first however many dollars for the first 30 hours. So for the first 30 hours of the week, and I guess it's worth noticing here that Harry has to work fewer hours before he reaches the bonus round, where he starts making more per hour, but then he makes less in, we'll call it overtime. He makes less in overtime than James does. So he's going to make 30x time, and we're going to add that to however many hours he actually worked minus 30, because this is so this value here, the total number of hours that he worked minus 30 represents the hours in excess of 30 where he earns his overtime rate of 1.5x. And that equals the amount that James made, which is 42x. So we can subtract the 30x right away, just to get these numbers under control. So we're left with basically just the amount that James worked overtime. And remember, h, the number of hours that Harry worked, that's the number we're solving for. So we just subtracted 30x from both sides. Now we want to divide both sides by 1.5x. So we end up with h minus 30 equals 8. Because we divided by 1.5x, the x's cancel out. 12 divided by 1.5 is 8. So then h equals 38 hours. Harry worked 38 hours to earn the same amount of money that James did in 41 hours. So basically, we have established that when it comes to overtime, or when it comes to hours in general, Harry has the better deal. These other numbers are just accounting for different errors in your computation. None of these are the partway through the problem trap answers. Choice D, correct answer. Okay, on to number 60. Still page 160. So we have 0.002%. We have 0.02%. 0.2%. 2%, I detect a recurring theme here, and then 20%. So really, these are all the same number. We've just been moving the decimal point slowly to the right. Each one moves the decimal point one space to the right. So clearly, there's going to the GMAT is expecting us to make an error in our powers of 10. Actually, we haven't even looked at the problem yet, and we know that. So a glass was filled with 10 ounces of water, and 1/100th ounce of the water evaporated, 0.01 ounce of the water evaporated each day during a 20-day period. What percent of the original amount of water evaporated during this period? So we have 10 ounces of water and loses 0.01 ounce per day for 20 days. So 20 times 0.01 each day times 20 days equals 0.2. And supposed to be a point there. Okay. 0.2 ounces total disappear. And so, of course, that's where this trap answer comes from. The issue here is that it's not what percent of 1 ounce, or it's not the number of ounces. This is the number of ounces. We need to know what percent of the original amount of water evaporated. So in order to figure out the percent, we have to do the amount that evaporated over the original, which is 10 ounces. So another way you can do this then is to, or an easy way to do this one, to figure out the percent, get rid of the ounces, they cancel out. We move the decimal point 1 to the right in the numerator and the denominator. It stays the same ratio. We end up with 2 over 100, which is a very easy representation of a percentage. 2%, because it's 10 ounces of water, not 1 ounce of water. And so that's where this trap answer comes in. So choice D is the correct one. It's 2% of the total. 20%, this would be true if it were just 1 ounce of water. So this is where the error of the power, one of the errors of the power of 10 came in. It was originally 10 ounces of water, not 1 ounce of water. So that one's not it. Choice D, correct answer. Okay, let's move on. Number 61. Three 5.0, 5.0, 5.50, 6.50, 6.75. Okay. So a glucose solution contains 15 grams of glucose per 100 cubic centimeters of solution. If 45 cubic centimeters of the solution were poured into an empty container, how many grams of glucose would be in the container? So really what this comes down to is two ratios that we have to compare. We know it's a 15 grams of glucose per 100 grams of solution, or per 100 cubic centimeters. So 15 G per 100 cc. The units aren't actually important on this one, but it's never a terrible idea to keep track of them so we don't confuse things. And then we have 45 cc's of solution over here, and we don't actually know how many grams are in there. But really this just ends up being an algebra problem. We end up cross-multiplying and solving for x. So we end up with, well, we multiply both sides times 100. To get the denominator out, we multiply both sides times 45. So we end up with 45 times 15 is 675. And then we have to divide by 100. So we end up with x equals 6.75. Choice E. So when in doubt, when you're given a solution issue like this, it's best to set them up as comparative ratios here, or equivalent ratios, because we know 3 of the 4 pieces of information and we just needed the third one. So and then we just solve for x. Okay. Let's see. We definitely have time for this one. Number 62. Let's see. We have 30, 35, 40, 70, and 100. In the figure above, if PQRS is a parallelogram, then y minus x equals what? I shall attempt to capture the glory of this parallelogram. It almost worked. And really, if it helps, you can imagine, these lines go off in every direction. Sometimes it helps when you're figuring out angles and things like that. We have some values to start. We have 140 degrees. So let's get these down. P, Q, R, and S. This here is 2y degrees, and then this is x degrees. Okay. So some things to know about parallelograms. Because they're parallelograms, the parallel line, it has some of the same properties of parallel lines. So what this means is that, I think I need to change the color. So that means that this angle here is going to have the same value as this angle here, because each of them is in turn complementary, as in adds up to 180 with this angle here and this angle here. So so angle P here, so 140, plus angle P equals 180. We don't actually need that for this, but it's useful to know. What it does mean, though, is that 140 is equal to 2y. 140 equals 2y in degrees, therefore y itself is 70 degrees. Now in this case, we're not asked for y, so that can't be right. We also know then that the opposite angles are going to be equal for the same reason, that this ends up being complementary to this and this ends up being complementary to this. To keep the color schemes straight, let's get these other angles right. So this angle and then this angle will be the same, which means this angle and that's supposed to be there. Vertical angles are the same, which means this one and this one are the same. Yeah. So it means then that x is going to be the complement of the 140 degree angle. So that means that just as this is 40, oh, that didn't work out quite right. Anyway, it is still true that as this one is 40, so x will also be 40. Which is, of course, one of our trap answers. We're not actually asked to solve for x either. We are being asked for y minus x. So in this case, y minus x is 70 minus 40. That equals 30. Choice A. If I could erase these dots, I would, but I can only erase the whole thing. It should be the angles opposite these here. It should be this one and this one that are green, matching these here. The rest of these are right. Anyway, choice A is the correct answer. And what's that next one look like? Yeah, I think we can do this next one too before it's time to end. So on to page 161, number 63. We have 10/3, 3, 6/5, 1/3, and 3/10. So if 1 kilometer or kilometer is approximately 0.6 miles, which is 6/10 of a mile, which of the following best approximates the number of kilometers or kilometers in 2 miles? So we're given a ratio here. We know if one of these, 1 km, is 0.6 mi. And of course, we don't really like having decimals in the denominator here. That makes our life uncomfortable. We can actually just move the decimal point of each of these over 1. So 10, I learned kilometers. even though there's no reason for it to be that, because it's also like centimeters, and the emphasis is on a different syllable, but that's the way it is in this country. 10 kilometers equals 6 miles. So then so that's what it is. We need to know the number of kilometers in 2 miles. So we can multiply the whole thing times 2 at this rate. So 2 miles times the rate of, let's draw a line here so it's not confusing, 10 kilometers divided by 6 miles. The two cancel each other out. Well, they don't cancel each other out. We end up with 2 times 10 is 20 over 6. And then we can simplify the fraction. It equals 10/3. Or, 10/3 of a kilometer in 2 miles. Okay, I think that's a good place to stop. So my name's Jim Jacobson. There, that's me. You've been watching Grockit's OGTV GMAT edition, where we're going through the 12th edition of the exam booklet, question by question, cover to cover, and doing the answers and showing you how we would do the work on the question. So come back next time. We will be picking up with number 64 on page, what page are we on? Page 161. We'll start off with 64 on page 161, and I hope to see you there.